Good afternoon, everyone. I'm Guoqing Pan from China, but now I'm a Marie Curie Individual Fellow in Malmö University. I'm sorry, I cannot speak Swedish, so I just using English. I try to learning Swedish every day. I meet my neighbor in Evaluate. I just say, hey, so I want to know more, but I cannot. Sorry for this. Apologize. So today I'll give a simple introduction about what we were doing in the field of materials. That is smart materials, intelligent materials, and it can be used in biomedical use. Also, I will give some detail described on what we are working on smart materials and for medical use. Okay. Before I say the smart materials that can be used in medicine, I can show you something smart natural plants. These are very interesting natural smart plants and can be respond to external stimuli, even rain or wind, or even you touch the leaf of the plants, they can shrink. So even though you know this venomous fly traps can capture the flies as food. When I was a child, I was really scared about this. Again, I worried about I will eat my fingers, so I never touched it again. But now I know this is just a science fiction. Yes. Okay, as you know, this is smart natural materials, natural plants. So can we make materials smart, intelligent, then respond to some external stimuli? As this is very interesting and also useful. Of course, we chemists can prepare materials and smart materials response to different stimuli like pH, value, temperature, also light. Even we can prepare some materials related to bio-related molecules like glucose. Also, our daily life, we know that when you play your iPad, your iPhone, when you touch the icon on the screen, you can open one of the maybe corresponding app as you want. So this is also a smart materials, maybe based on the electric and mechanical. So it's very useful in our daily life using smart materials. Okay, next I will introduce several samples about these smart materials that respond to different extra stimuli. The first one is small response for smart materials. With these materials, it's very interesting. They can respond to temperature. With different temperature, they have different chemical structures or even the material structures. For example, this is a very interesting magic coffee mug. Yeah, it is based on the small response materials and the coating on the outer surface of this cup, the mug. You can buy online, maybe 15 kron, even cheaper. When you use this coffee mug, you add the hot coffee in, the color change from the original black to white. This reminds you that the cup, whether it's hot enough, and you will maybe burn your lips, tongue. It's very good for thermal sensing. But I will say much more about this thermal responsive for biomedical use later. Next. Another one is magnetic responsive for smart materials. This magnetic responsive materials is based on iron, or it's oxide, ferroferric oxide. When I was a child, I really liked to using a magnet to attract everything I want, from bedroom to kitchen, or even my glass, the pens, or even some small screws. So it's very, attract the attention by a child. But most important, I think, in biomedical use is magnetic resonance imaging. With this is very useful technologies when you can find in every hospital. This is technology to make a picture of your organs or tissue structure in the body, And we using the magnetic responsive materials, we can get a much stronger signal, and the picture or the image will be more clear for diagnosis. So this is very useful in medicine. Okay, next one is fluorescence materials. These fluorescence materials are very colorful. It's very colorful and different colors. They can sense to the outside temperature, or even some bio-related biomarkers to censor this for diagnosis your disease. This is very useful. But we also can find this kind of fluorescence materials in our daily life. For example, this is light stick for concert or some activities for celebration, but do not to hide to when you go a concert, because I mentioned you this materials inside of this sticks is in the majority of cases is toxic. Be careful. Okay. I like this glucose responsive materials. This is really related to some biological systems. Glucose responsive is also biomaterials can respond to glucose. They can change the chemical structure on a different concentration of sugars. So scientists designed a contact lens that can respond to glucose, and then they shoot different colors. It is color changing contact lens to detect your glucose level in the blood. So this is amazing. This is awesome. That you different from some other detecting method. You need a needle punch, and then you grimace pain. So this you can just use a mirror, and you find the color in your contact lens changes. You need to take a medicine. So this is very useful in the future for diabetes. Okay, no, I introduced a lot of samples because time limited. I cannot say much more about this. A lot of smart materials. What I want to say is what we were doing. So we were doing also some more responsive materials, as I mentioned them before. We use these smart materials for regenerative medicine. For example, we designed the hydrogels that can respond to temperature with different temperature. The size is different. And also inside of the material, they have the small response for binding sites. Our body temperature is 37 degrees C. They can bind in some biomolecules, and lower temperature, they release. Need to mention this, the biomolecules can bind into cells. So if we use this material to culture cells, they can bind them at the maybe body temperature, and we we reduce the temperature to 20 maybe. They can release the cells. So by using this method, we can harvest a layer of cell sheet just by changing the temperature, and also we can fabricate multiple layers of the cell sheet. This is the intact cell sheet, and also they are alive. The cell and cell interaction is similar to our tissues, so we can use this layer or multi-layer cell sheet for some tissue organ repair. For example, we can use these tissues with this cell sheet for bone healing. If we use a bone cell sheet, and covered on the defect of the bone, the bone fraction is a common injury in our daily life. If we use this method, we can just cover the bone defect with this cell sheet, and after 8 weeks, we can find the defect heal off all. But the control ones, we can see without any cell sheet covered on the surface, the situation become worse. So this is very useful. Also, we can use this cell sheet for our skin repair. Skin is a two-dimensional structure. Also, our cell sheet is a two-dimensional structure. So with this cell sheet, we can fabricate a multi-layer and cover down on your damaged skins, maybe bone or squad. You can imagine is much better than you just cover with medical gauze. So this is useful. Of course, the scientists working on this for many years. With the continuing effort from scientists, we can repair a lot of tissues or organs in our body. For example, esophagus, periodontal, lung, liver, your cardiac, cartilage, even from up to bottom. You can imagine all of the organs or tissue you can repair by these technologies. Because time is limited, I just want to say something more important than what we were doing inside of these materials. That is, how could we create? I just said create the regulation site for some biomolecules. This is also smart materials and combining a specific binding, specific regulation of some biomolecules. This is the core of the smart materials that we are using. So we were using a molecular imprinting. Imprinting is a process similar to print. We know print. We can using a leaf with a pen, and you print your leaf on the paper. You use with your fingerprint on the paper. Also, you know, when you're walking on the sand beach, you leave your footprint in the sand. And the last one is Chinese traditional steel or stamp. You can see this fish fossil. I think it is tragic, but I think it's great. He do printing with his life, very good. So we were doing it different from this such printing process. We're doing the world's smallest printing. We've been printing the molecules. Sometimes the molecule is just nanometer scale. Nanometer is 1/1 billion meter. It's very small, so we do the smallest in the world in printing. When we remove the molecules from the matrix or polymers, we can obtain this kind of smart material with the specific binding site for some molecules. So I can say some things in details how to prepare this. Prepare the molecular imprinting the matrix or polymers. If you want to imprint in molecules, for example, this is a real chemical structure, and then the cartoon. We need the monomers. Then these monomers can interact with these molecules, and then they can capture with using different bond, maybe chemical, chemical bond, hydrogen bond, or hydrophobic interactions. And then we fix this network with some cross-linkers. We remove these molecules. We can obtain this smart materials with shape, and the interactions is very useful to capture the molecules. So this is a very useful and efficient concept to create synthetic materials, smart materials, and can bind into some bio or some organic molecules. If you want to know more about this, you can welcome to our lab in Populärvetenskaplig, Hausenwagen 23. Professor Selgren is in charge of our research group. We have a lot of experts working on molecular imprinting. So if you want to know, you can get answer there. Okay, time is fine, so let's summarize. It's too quick. So our chemists can create smart materials. Also, in our lab, we can create smart molecular imprinting polymers that can specific binding to a molecule. It's called molecular regulation. Also, with these smart molecular imprinting polymers, we can use for regenerative medicine. So this is a great potential, great promise. So finally, so we say something bigger. We chemists can repair bone, repair your skin, or some other tissues, organs, and so on. Finally, thank you very much for your attention. And I think we love science. If you love, maybe it's good for the development of the social society. Thank you so much for attention. Is there any questions you can ask?